Hello, my name is Mark Ellis from Stick and Rudder Studios, and today I wanted to give you a demo and a short tutorial on a new product that we're working on called X-KeyPad. And what X-KeyPad is all about is it basically does two things. One is it allows you to collect numeric data from either a numeric keypad or anything that you can map either joystick buttons or a keyboard to. And then once you've collected some numbers, you can then have a series of commands that you could execute either through mapping through joystick buttons or keyboard keys that will take that number that you put in and set it to any one of the sim variables that have a numeric value behind them. So as an example, say for instance I wanted to set my altitude to 5,000 feet. I could simply type in 5,000 on the keyboard and then press a button that I've got mapped okay to a command to set the altitude variable. Now what something like this will do for you is it reduces the number of rotary encoders that you might need in a cockpit. I mean, there are devices like the Cytec panels, that can handle this and can do this. There are also more expensive equipment out there that you can get that has a bunch of these rotary encoders on them. But the challenge with them is they either tend to get very plane specific, or there aren't enough of them. In other words, there's so many sim variables that you might want to set from a rotary encoder standpoint. Altitude, heading, course, any of your comm frequencies, your nav frequencies, things like vertical speed. So there's so many of these variables, and if you really look in a real cockpit like a 737, there are a lot of these darn rotary encoders. And yes, you can develop a cockpit that has all of these in there, but the hardware starts to get very expensive, and it takes up, frankly, a lot of space. If you're like me, I have limited space. I like to fly a lot of different kinds of planes, and what I'm looking for is something pretty generic, okay, that will allow me to fly these planes and it not take up too much space. And I think what X-KeyPad does is it allow you to do that. Now another aspect of X-KeyPad is I've specifically designed it to work with the PI Engineering's X-Key devices. And one of the things that you can do if you're using these devices is through Lua scripting or through a common delimited file, X-KeyPad will allow you to control the backlighting on those keys. And why don't we take a look actually at an X-Key device. I've actually got one right here that I bought. It's called an XK60. And they've actually make a number of different devices like this. There's an XK80, which is the same form factor as the XK60, except that all of these places where you've got blank rows, there's actually buttons there. They make a smaller one. I think it's got like 24 keys on it. They make another one that's really pretty large. It's got 128 keys on it. And what's really nice about these devices is all of these keycaps, you can change the legends on them. All you have to do is pop the little cover off, and you either could put a printed piece of paper underneath there. I did mine by doing a layout, and then I had it printed on basically transparency, and then cut the transparencies out and put them underneath each of the LEDs. And this device can be programmed to either have each of these keys look like a joystick button or a keyboard key. And they're pretty easy to program to whatever you want them to be able to do. So they're actually great for interfacing to simulators. I mean, they can be used for a lot of different things, but they're great for that particular aspect of it. Now again, going back to what I said with X-KeyPad, it does have the ability to take numeric data and put it into any sim variable. And for that, you don't necessarily have to have an X-Key device. It'll work with anything, a keyboard, maybe you've got the Thrustmaster Cougar MFDs, those pair of MFDs that have got a lot of buttons around them. Anything that would allow you to associate a command with either a keystroke or a joystick button, you can use with X-KeyPad to set these numeric variables. But if you want to change the backlighting of any of these things, X-KeyPad specifically will allow you to program the backlighting on any of the X-Key devices. So what I want to kind of show you today is the things that we can do with X-KeyPad. So why don't we go ahead and get the simulator up and running, and I'll give you a real quick demo of some of the simple things that you can do with this. So I've got X-Plane 11 here, and I'm going to fire this up so that it's in the Cessna 172 with the G1000, and I specifically picked the G1000 because there's actually a lot of data on that G1000 screen that you've got, and we can actually see how X-KeyPad can set a lot of these numeric variables. So while we're waiting for the simulator to come up. Okay, so we have the simulator up, and I'll bring this to full screen here, and I'm also going to come on down and bring up a close-up view of the PFD so you can actually see what's going on here. And let's do something pretty simple. I have got a key set that what I can do is I can program the transponder code, which is a common thing that you have to put in. And as you can see here on my X-Key device, I have these numeric keys here that I have simply mapped to some of the X-KeyPad commands to help collect data from anytime I press these keys. And what I'm really looking to do is build up a numeric data buffer with some numbers in it, and then when I execute another command, it's going to actually set that. So let's take an example. Suppose I want to set the transponder to 5353. Okay, I simply come in here and I press 5353, and you could see that X-KeyPad brought up this little window here, which you can move around. As an example, I'll move it up over here, and it's collected the numbers 5353. Now if I come back over here to the X-Key device, I actually have this button here, transponder ident, and I'll show you how I configured this, that when there's numbers in the number buffer up here, 5353, or any numbers that are in this window, when I press this button, it's going to set the sim variable for the transponder code. And I'm going to do that right now. And if you'll notice down here, the transponder code changed to 5353. Let's do that again so that you can watch it. We'll do 1254 as an example. Notice that I've collected those numbers up there, and then I'm going to hit the transponder ident down here, and sure enough, that code has been set. Same thing's true for something like altitude. Right now I've got my altitude set to 6,810. Let's assume I want to set that to 5,000. Just come in here and put in 5,000, and I've got the altitude button set over here so that it changes that numeric variable. So pretty much anything you could set in here. Let's take an example of, let's say COM1. Let's say I want to set COM1 to, 123.5. So I'll put in 123.5. And I just come over here and set COM1. And sure enough, you'll see the COM1 got set to 123.5. So I could do this with a wide variety of numeric variables. Altitude, vertical speed, course, any of the comm channels, your COM1, COM2, nav1, nav2, ADF, your transponder mode. Barometer is another good example. Right now I got the barometer set to 30.02. Let's say I want to set that to 29.92. Just to 29.92. And I've got the barrel key over here set to that. So as soon as I press that, sure enough, the barometer goes to, or altimeter goes to 29.92. So again, you don't need an X-Keys device to do this. Anything that you could map some numeric numbers to, whether that be your numeric keypad on your keyboard, it could be a little sideline numeric keypad, a little USB one, okay, that you buy, that you can map to commands to collect these things. And then all you need is some way to map a command to a button press or a keystroke. So you even could do this where you have a number of your keys in your keyboard set up where you'll type in numbers on your keypad and you'll press maybe the A key or the D key, and that will be set up to set that particular variable. Okay, so that gives you kind of a demo of what X-KeyPad is all about and what it can do. I'll give you a little bit another example of backlighting. I've got the X-KeyPad program that anytime the comm monitors are on, it'll change the backlighting on the LED from blue to red. So say example, I have COM2 here. If I press that, meaning I'm monitoring COM2 at the same time I'm monitoring COM1, notice that the backlighting on the COM2 LED goes on. Another one I've got programmed is if I tell the transponder to go to ident mode, I've got a program that while it's identifying, okay, and you can see that down here where it's got ident on the G1000, this will flash red. And as soon as the ident mode goes off, which it does after, 20 or 30 seconds, I can't remember exactly what the length of time is, you'll notice that this will go back to a steady, blue state. So through a set of configuration files, you can control the backlighting on any of these, and the backlighting can be driven, excuse me, either by datarefs, or you can even use Lua scripts, to change and control the backlighting, and that's specifically for the X-Key devices that we can do that with. Okay, so let's talk a little bit about how this works. Okay, first thing I would do is show you some of the mappings. Okay, if I come up into here and I go to keyboard, and I come down here to SRS, and I go to X-KeyPad, you'll see that there are a number of commands here that you can set. And in order to make it so that you can collect this numeric data from something other than just the numeric keys on the keypad, you can basically program any keystroke or any keyboard button to do these things. Like here you'll see adds a 0 to the number string, adds a 1 to the number string, clears the number string, which is the same as this kind of clear button that I've got over here, adds a dot to the number string, puts a minus, in the number string. So what I've done is I have this X-Keys device programmed that, as an example, the 7 actually sends out a Shift K. So when I press 7, it's actually going to add a 7 to that number string buffer, that little window that kind of popped up as I was typing things in here. Okay. There are also a set of commands down here that you can use to set any dataref. So let's say as an example, what would be a good one that I could do? Baro is a good one. Barometer. There's really no separate command behind barometer. So what I've got that set to is, and we'll show you the file that actually does this, is there's a command for setting dataref number 7, which I'll come down here. And I've actually done this with a joystick button, as a matter of fact. If we come in here and we take a look at the HD80, and I'll press this barrel button down here, you'll see I've got that set to set keypad sim variable dataref number 7. And I'm going to show you, where you actually configure these and what datarefs it actually controls. This is a little bit of a complicated concept, but I just wanted to show you, where these commands are and how you map them to either keyboard keys or joystick buttons. Okay, let's take a look at one of the main configuration files. The first one is a simple comma delimited file, which is named X-KeyPad _ datarefs.csv. And you could actually have one of these for each aircraft type if you want. The way X-KeyPad works is very similar to the way X-SciTech panels works. It'll first look for one of these configuration files in the aircraft directory. If it finds one, it's going to read that and it'll use it. If it doesn't find one in the aircraft directory, it's going to look for one in the X-KeyPad directory, which is going to be in your plugins folder, and it will read that. So let's go through and see how this works. So the layout of the comma delimited file, and by the way, I use Excel for editing a comma delimited file, but you can use Google Sheets. There are probably a number of other tools out there. You can actually use a plain text editor too, because it's just a text file, but I find something that's uniquely designed to read comma delimited files and let you deal with them in columns like this is the best thing to try to use for this purpose. Okay, so the definition is pretty simple. Column A is nothing more than a name that you want to give this particular dataref. And you see I've got some things here like altitude hold, vertical speed, auto throttle, heading, transponder ident in mode, barometer, COM1, COM2, NAV1, NAV2, ADF, and so on. Okay, and each of these commands or buttons has got a data ref behind it that I want to be able to set with some numeric information. Okay. The next thing you have is your data ref numbers, and these run from 1 through 50. So you can have up to 50 of these data refs that you can control through numeric input, and it's very easy for me to add more. I personally think 50 is going to be more than enough. I mean, I've got 17 in here, and I was starting to struggle a little bit with what else I might want to add in. And then you've got the data ref, which is the actual data ref reference in the simulator that you want to set. And you could see all of the data refs that are possible by looking at a file called datarefs.txt, which is in your Xplane 11 resources plugins directory. There's actually a reference there that tells you what all of these data refs are. Then there's a thing called Piggyback commands, which I'm going to go over in a few minutes, because this is another bit of an interesting, complex concept that I want to get through. You can do things like add a multiplier. This is particularly useful as an example for the comm frequencies. The simulator wants these in 10 hertz or kilohertz, 10 kilohertz increments is what it wants. But for us to put it in, it's much more intuitive to put them in megahertz, like 123.5 megahertz. So they've got to be converted. So if I put in 123.5, the number 123.5, I got to multiply it by a value of 100 to get it into the units that the data ref wants it in, which is in 10 kilohertz increments. If you don't specify this, it's not going to do any multiplication. You can set a min and max value. So as an example here, I have on the vertical speed, I'm not going to let you set it to anything less than a minus 3,000 feet per minute or 3,000 feet per minute. Okay. Altitude hold, it's got to be between 0 to 40,000 feet. Okay. Transmitter code 0 to 9999. That type of thing here. On the things like the courses, you can set it between 0 to 360. Okay, as an example. Flight level change, 0 to 350 knots indicated airspeed. If you don't put a min-max in, it's going to let you put any value you want, and it'll try to jam that into the data ref. And depending on the data ref, if you put invalid data in it, it could cause the sim to do some crazy things. It could potentially even crash the sim, depending upon what you're doing. So it's a good idea to think about mins and max, particularly if they're areas where they make a lot of sense. Okay, that you might want to do something here. Here's an example on heading here. I don't have a min and a max in here, but it probably should have one. 0 to 360 is probably a reasonable thing to put in there. Okay, so let's take a look at a simple one first. Okay, which is I'll take the baro as an example. So on the barometer, anytime I have a number entered in there and I execute that command in X-KeyPad to set data ref number 7, what it's going to do is it's going to jam that number into sim cockpits to gauges, actuators, barometer setting, inches in mercury. Okay. So that's a pretty simple one, okay, that specifies how you do that. And if you remember correctly, I have this baro button over here mapped, okay, to that X-KeyPad command, okay, set data ref number 7. That's how that kind of maps out here. Okay, let's take a look at a piggyback command. So piggyback command is a way to double up on buttons, okay. So if I take a look at this one, COM1, I've actually got COM1 here set to execute the command to toggle the audio panel monitoring of COM1. Same with COM2, NAV1, NAV2, etc. These are actually mapped, okay, to this command over here, sim audio panel monitor audio COM1, 2, and so that's what these buttons here are mapped to in the simulator. Okay. Now what X-KeyPad will do, anytime you have a piggyback command referenced in here, is it will basically register a callback to Xplane saying, anytime that command is executed, please give X-KeyPad an opportunity to take a look at it and decide what to do with it. Okay. So what X-KeyPad does is it's going to monitor any of these piggyback commands. So an example, when I press COM2, on and off. X-KeyPad's going to get it. It's going to see when this comes in, and it's going to make a determination. First, it's going to say, are there any numbers in the number buffer? If there are no numbers in the number buffer, then go ahead and pass this command directly onto X-Plane, and what X-Plane will do is it'll simply toggle the audio monitoring on and off, okay, for COM2. If I do have a number in the number buffer, then what it's going to do is not pass this on to X-Plane. What it's instead going to do is take the number and it's going to put it into that variable. And if I actually move this out of the way here, we can see the way that works, okay? So I'll go back over to COM2. Let's say I currently have COM2 set to 122.8. Let's say I want to set to 125.4. So I'll type in 125.4. You'll see that I've actually got a number in the buffer. And if I come over here and hit COM2, it's going to set the sim variable. And if I don't have anything in the number buffer, it's going to turn COM2 monitoring on and off, which you can actually see over here on the G1000. Same if I come over here and I click on the monitoring on nav1. Notice how it's turning the audio panel on and off for that. So I think that gives you kind of an idea of how these piggyback commands work. It is a little bit of a unusual concept to get your head wrapped around, but I think once you get the hang of it and you take a look at the sample file that we've given, I think you'll get an idea of what it's all about. We've already talked about the multiplier. This is particularly useful as an example, for the COM frequencies because, again, what the dataref wants is 10 kilohertz instruments, which from a human perspective makes more sense to put in is megahertz, and you've got to multiply it to get it into the right units, that the dataref wants. Min-max, we already discussed this. If you put in values that are less than or greater than, it's basically not going to try to jam those into the dataref. Now the next one that's interesting is the increment flag. So let's take a look at this transponder mode. Now the transponder mode, this dataref, Sim Cockpit Radios Actuators Transponder Mode, it's actually an enumeration. And it has 4 values. 0, which is when the transponder's off. 1 is in standby. 2 is in on. And then 3 is when it's actually in altitude mode where it transmits your altitude out over the transponder. So, we either, so common thing with this is you could turn around and have 4 buttons, okay, for setting those transponder modes to the different things you want. That's kind of a pain in the neck. So what I allowed X-KeyPad to do is allow you to go through an increment type of a scheme. So when you execute this command for setting dataref number 6 in X-KeyPad, what it's going to do is going to look at the current state of the transponder mode, and it will increment it by 1. If that incrementing it by 1 makes it go over the max value, it'll set it back to the min value. So it'll kind of go 0, 1, 2, 3, back over to 0. 0, 1, 2, 3, back over to 0. So let's actually take a look at the way that works. So if I come over here, you'll see the transponder right now is in standby. As I hit the transponder mode button over here, this should increment. It goes to on, it goes to altimeter mode, off. Standby, on, altimeter mode, off. That is also useful, okay, for the CDI selector, which I have another one over here that I've done, which is the HSI selector. This is the thing that lets you select either GPS, nav1, or nav2 for your input to the autopilot and the flight director. So you can see same thing here. This is the dataref. It's like an enumeration. And it's got a value of 0, 1, or 2, which is either GPS mode, nav1, or nav2. And then this simply says that whenever I execute that command, set dataref number 16, if I see whatever value set in, I want to increment it. And let's take a look at how that looks. So I come up over here, you'll see right now it's set to GPS mode. Where's my CDI button? I've got it right over here, okay? So as I press this, it goes to VRR1, VRR2, back to GPS. Okay, so everything I've shown you up until now simply works with command mappings. So again, you don't need an X-Keys device to do this. A keyboard, anything that's got a bunch of buttons on it, a number pad can make this work. I mean, I'm actually going to be interested to see what people come up with, okay, for things that they could, use to make this work. I also took a look at, and the documentation says this, another interesting device which are fairly inexpensive are these pause keyboards. These are the keyboards they use for point of sale, systems. Typically see them in like restaurants and stuff like that. And what's nice about these pause keyboards is they act like a regular keyboard, but the legends behind them, you typically can pop them off and you could put something else underneath them. So they're really great for doing something similar to what we did over here with the X-Key device, but most of the ones I've seen, they don't have any backlighting on them. So they're quite a bit less expensive than these X-Keys devices. This X-Key 60, if you're in the US, you can get it from BH Photo. I think it's for $185. I've seen the Cherry Pause keyboards for things like $108. And they've got a lot more keys on them. They've got like 100 and some odd keys on them, all of which, okay, the legends can be popped off and you can change them. So that part of X-KeyPad will work with pretty much anything. It's kind of device agnostic because of the way it works. Now the next thing though is let's talk about how we program these LEDs. So there is another configuration file, which I'm going to bring over here real quick, if I can find it. Here it is. And it's called X-KeyPad LEDs.csv for the LED backlighting. And again, like the datarefs, the way X-KeyPad will work is it will first see if it sees one of these things in the aircraft directory for the plane that you're just currently loading. And if it does, it'll read that and use it. If it doesn't, it's going to look for X-KeyPad LEDs.csv in the X-KeyPad directory in your plugins directory folder. Okay, what that's going to allow you to do is you could have different backlighting schemes. What's more common is the data refs to drive these LEDs. They may be different based upon different planes. Not all planes necessarily follow the standard autopilot data refs. Like if you get in the Zibo 737, there may actually be a set of custom data refs that you're going to want to specify to drive the backlighting, okay, on some of these things. Okay, so let's take a look at the way this works. First off, understanding this key numbering. I've actually got an image up here that I should be able to bring up. Let me bring this over here. So this is the layout of the numbering scheme for an XK60 and an XK80. They're basically the same device. The only difference is the XK60 has a set of keys that are removed, which lowers the cost a little bit. Kind of gives you a nice ability to group things, but you only get 60 keys, whereas in the XK80 you get the full 80 in this grid type layout. The keys are numbered 0 down through 7, and then 8 through 15, 16 through 23, all the way up through 79. Okay, and if you had the 128 key device, it would go 0 all the way through 127. Let's move this out of the way. So if I come back over here and I look at the spreadsheet, similar to the dataref one, column A is simply a name, so that you know what that key is that you're trying to program the backlighting for. Then you've got the key number. 0 in my case is this autopilot key. 1 is the flaps down key. Key 2 is blank on the XK60 here. It's not here. 3 is the COM1 key. Okay, and let's take a look at what I would consider to be the simplest things. Okay, what's a good example? The barrel key is an example. All I want to do is have that guy have the blue LED on it. It doesn't really have any programming behind it besides that, okay? So what you're going to see in the next set of columns is, first there's a data ref, if you want to use one to drive the LED backlighting. If you don't want to do that, you just want to kind of hardwire the backlighting to either blue blinking, red, or red blinking, or nothing, all you have to do is set numbers in these variables. The next columns are bank 1, which is the blue LED on, bank 1, which is the blue LED blinking, bank 2 is the red LED on, and bank 2 is the red LED blinking. In my case here, I've got a 1 in here. And the way this logic works is X-KeyPad is simply looking to see if the cell evaluates to a true state. And in programming, particularly in C++, which is what X-KeyPad was written in, any non-zero value is considered to be true. So if I put any number in here besides a 0, it's going to be considered to be true, and it will light the blue LED. And the way the evaluation works is it always starts first for the on condition. If that evaluates true, it's going to light the LED. If that does not evaluate to true, it'll come over and take a look at the blink value. If that evaluates to true, it'll blink the LED on and off. So let's try something simple. What I'm going to do is set this value to 0, and I'm going to save this file. I'll just move this out of the way real quick so you can see this. And up here under the plugins command under X-KeyPad, there's a reload configuration files. Now if you watch carefully, this barrel key should turn off, which it did, right? If I come back over here and let's say I set the blue blinking value to 1, and I may have to make sure that this is non-true, which is 0. I'll save that. And I'm going to come back over here and I'm going to reload that file. And the barrel key is now flashing blue on and off. And I could do the same thing with red just to show you an example. And by the way, the blue and the red are independent of each other. So I'll give you an example. I'm going to leave the blue LED on and I'm going to set the red LED to blinking. And we'll come up here and we'll reload that configuration file again. And what I do something right here. Let me come back and look at this. There we go. And you'll actually see that we've got both the blue and the red blinking at the same time. Okay? That gives you an example of how that works. Okay? All right, let's take a look at something a little more sophisticated. Let's take a look at the COM1s. So here's a dataref that X-KeyPad will monitor and take a look at. And this dataref, audio selection COM1, it is a 1 when we're monitoring COM1, and it's a 0 when we're not monitoring COM1. And the way this works is it's a simple ANDing operation with an ability with this exclamation mark to basically invert the logic. So let's take a look at this. When this dataref is a 1, when I AND it with another 1, I'm going to end up with a true value. Okay? If this were a 0, indicating a COM1 was not being monitored, when I AND it, logically AND it with a 1, it'll actually evaluate to false. Okay? So in this case, when COM1 is being monitored, okay, bank 2 is going to be on steady, which would be the red light on. Now over here, I've got sort of a similar thing, but I've inverted the logic. I said when COM1 is set to a 1 and I AND it with this 1, which would end up being true, whenever it's not true, I want the blue LED on, right? So that basically says anytime the COM1 is not being monitored, blue LED is on steady. Okay, so that's the way that little not symbol works. It basically inverts the logic. You still have to do the ANDing to evaluate whether or not it's true, but then it inverts it around backwards. Okay, to not do it. I know it's a little complicated. In the manual, I've given you a link to a Wikipedia entry that kind of explains to you how this logical ANDing works. Once you get the hang of it and you see these examples here, it'll make more sense, but it is a little tricky to initially figure out how you want to use it. Here's something that's a little bit more complicated. Okay, let's take a look at the nav backlighting. Now with the nav, you got this concept of and I'll actually bring up, I have a document here, a page that has also got a link to it in the documentation that kind of shows you what I mean by these bit values. So first off, the variable we're looking at is called the autopilot state. And this is an integer with a number of different bits set in it that mean different things based upon what you've got. Okay? And the two we're interested in nav is your horizontal navigation, armed or engaged. So as an example with the nav button, say for example a VOR, you may turn that on, but you're not within the limits of what the VOR can pick up. Okay, so it might actually be kind of in an armed mode, and as you get actually a little bit more angled in to where you're within the bounds or the limits of where you've got a good signal from the VOR, it'll actually go from being armed to engaged. So there's actually three states with nav. It's either off, it's armed, and it's engaged. You have the same thing true with the glide slope. You probably have seen this, okay, in particularly in the SciTech panels, when your glide scope is not captured yet, but you've got it turned on, it goes to armed, okay? And when it actually captures the glide slope and starts to descend the plane, it'll go to engaged. So these are the bit values, okay, in decimal for those things. When it's obviously when it's off, you get 0, and we'll use the glide slope as an example because it's the same concept. So in this case, the decimal value is 1024 when it's armed, and it's 2048 when it's engaged. Those are just basically two different bits, within that value. So what we've done over here, and let's actually come down and find the place where I've got approach, right? This is a good one to take a look at it. So I said, when it is armed, which is the 1024 value, I want the red light to be blinking, indicating that it's armed, but I haven't captured it yet. If I see that it's gone to engaged, in other words, the glide slope is captured, which is the value of 2048, I want the red LED on steady. And if I add these two values together, I get 3072. And in this case, if I see that either one of them is on, right, and I invert that value to a not, which is what the exclamation mark says inside of it, it says I want the blue LED to be on all the time. So if it's neither armed nor engaged, then I want the blue LED on. If either one of them goes to armed, or if either one of the bits go on, either armed or engaged, then what's going to happen is this value gets inverted and the blue LED will be off. And again, I recognize that's a little complicated to kind of keep your wits about you how it works, but if you experiment with it and you read about how logical ANDing works with bit masks, then this will make a bunch of sense. And again, you can use this default sort of sample CSV file that ships with X-KeyPad as a way of kind of experimenting and see how the whole thing works. Okay? Now, another way you can program this is with Lua scripts. And I'm going to show you a Lua script that does this a little bit more in a more complicated fashion. So the spreadsheet works fine in a situation where you've got a single dataref and you're looking at its value. But what if you got something a little bit more complicated? And a more complicated thing, let's say as an example, is our gear, our landing gear. And I've actually got this guy here programmed to do some rather interesting things. The way I want this one to work is, if the gear is down, I want it to be blue. If all three gear, the nose gear and the two left and starboard and port main gear are up, I want this LED to be red. And if any of them are in transition, in other words, they're not fully up or not fully down, I want this to blink. Okay? So there's no way to do this in the spreadsheet, because frankly, you've got to look at three different data refs, or it's actually three elements of an array of a data ref to do the calculation. So here I've got a little Lua script, which by the way does ship okay with X-KeyPad. You could take this guy and dump it into your Lua scripts directory, and this will actually execute. So this obviously is only going to make sense to those of you who know how to write Lua scripts. But up here we define some data refs, and these are the X-KeyPad data refs. There's basically an array of 128 integers for the red bank, and there's an array of 128 integers for the blue bank. And the value of these integers is, if it's 0 for that particular key, it means off. If it's a 1, it means it's on, and if it's 2, it means it's blanking. So you either could set any red LED between 0 to 127 for the 128 key X-key device, to either 0, 1, or 2 for either, the red LED either off, on, or blinking, and the same is true with the blue LEDs here. Okay. Now in my case, this gear toggle button is actually button key number 51 on this. If you remember that picture over here that we had, we'll bring that over here real quickly. Bring this back into view. It's 51. That's this one right here. Okay, and that's the one we're going to want to set. So I've defined a data ref here. Gear red LED is the red LED array, element number 51. The blue is the blue LED array, element number 51. And here are the gear data refs. And this is basically in Flight Sim Model 2 gear deploy ratio. 0 means that the gear is not deployed at all, and a 1 means it's fully deployed. And these are floating point numbers, so anything in between, like 0.1, 0.2, 0.3, 0.4, it's kind of a percentage of how much of the gear is deployed. So if you come down here and take a look at it, if I say that the nose gear is fully deployed, and the left main gear is fully deployed, and the right main gear is fully deployed, okay, then what I want is the blue LED on and the red LED off, okay? Otherwise, if the nose gear is fully retracted, and the left gear is fully retracted, and the right gear is fully retracted, then I want the red LED on, and I want the blue LED off. And if it was neither this one nor this one, then it must mean that one of the gear, somebody, okay, is in transition or it's stuck. In that case, what I want is I want the red LED blinking and I want the blue LED off, okay? And this little thing down here, do often, this function, evaluate gear, I believe do often in FlyWithLua means it's going to get checked every second. So every second we come through here, we take a look at this, and we set these lights depending upon what's going on with the gear, okay? So you could do that stuff all with FlyWithLua. As a matter of fact, all the things I just showed you in the common delimited file, you could actually do it all with Lua scripts if you wanted to. I think it's a lot more complicated, and you need to have the Lua programming skills to be able to do it, but you can go, pretty crazy with the LED backlighting. So I think that pretty much kind of goes through what X-KeyPad does and how you can program it. It is a little challenging to set up because you obviously, if you're using an X-key device, you do have to set this up to indicate whether these things are going to be replicate keystrokes, or they're going to replicate a game controller button. You may not have to do that with something like a pause keyboard. They may come already programmed with keys, but typically these devices, you've got to set them up for how you want them. And then you've got to go in, you've got to do all the mappings, and you've got to set up the CSV files. Although I give you, the two samples, okay, of the LED backlighting and the dataref common delimited file that you can look at as an example. And all you really need to do is just change those around to what keys you want to be what and what commands you want to map them to. But once you get it all set up, it actually works pretty darn good. And what I like about it is for a relatively inexpensive amount of money. And as an example with this one here, you're talking about a device that's $185, and it'll probably be a nominal fee for X-KeyPad. I haven't decided what to charge for it, but it'll definitely be under $10. You can get an extremely powerful device. I mean, take a look at all of the things that I can control with this, as well as all of these numeric values. I mean, this thing here, button-wise, and if you had all the rotary encoders to do all the various things, you're probably looking at a device that could probably cost you $500 or $600. And you get away with something that is pretty programmable for maybe $195 or $200. And if you actually even went with something like a pause keyboard that's less expensive, you could be down to $120, for something like this. And if you really wanted to go cheap, you could probably make this stuff all work with your standard keyboard. If you wanted to. It maybe not be quite as intuitive. You need to remember what keys are associated with what data wraps and that type of thing, but you can do quite a bit. Okay, with it. So that's it. Thank you very much for listening. This is a relatively new product. We're still working the kinks out on it. Maybe there's some things we can do to make it a little bit more intuitive, to make it work, and we certainly look forward to getting all of your feedback on it. And again, thank you very much, and look forward to people taking advantage of X-KeyPad.